Unit 2 concerns the property of liquid solutions. This is the lecture for Module 1, which is on units of concentration. Now we all know that a solution has two components, a solute and a solvent, and we have seen that molarity is moles of solute per liter of solution. And we've worked extensively through molarity in previous courses. Because the volume of some solutions is sensitive to temperature, chemists have also defined temperature-independent concentration units. One of these you may already be familiar with. Percent by mass is mass of solute over mass of solution times 100%. Another is molality. Molality is moles of solute per kilogram of solvent. Consider the mixture below. 23 grams of ethanol, molar mass and a formula for the species are presented, is dissolved into 85 grams of water. The total volume of this solution, we are told, is 100 milliliters. You should be able to answer the questions before continuing. What is the solvent and what is the solute? What is the mass percent of the solute? What is the molality of the solute? What is the molarity of the solute? Stop now and attempt these questions before continuing. Because there is less ethanol than water, we will consider ethanol the solute and water the solvent. The percent by mass of ethanol is mass of ethanol over the total mass, or 23 grams divided by 85 plus 23, mass of the ethanol and the water, multiplied by 100, or 21.3% ethanol. Naturally, by mass, the solution is 78.7% water. Molality, moles per kilogram of this solution, are moles of ethanol solute over kilograms of solvent. Grams to moles conversion tells us that 23 grams of ethanol divided by 46 grams is half a mole of ethanol, 0.500 moles. And we find mass of, or rather kilograms of water by dividing 85 grams by a conversion factor of 1 kilogram over 10 to the third grams. And naturally, this means there will be 0.0850 kilograms of solvent. We then calculate the molality and determine a value of 5.88 molal, or 5.88 moles of solute per kilogram of solvent. Correcting for sig figs right here. There are, again, the molality of the solution is 5.88 moles per kilograms. Now, to find the molarity of the solution, we divide moles of solute by liter of solution. We know from before that there are 0.5 moles of ethanol. We have been told the volume is 100 milliliters for the total solution. 0.5 divided by 0.1 gives a molarity of 5 moles per liter, 0.5 molars. Note that the answer is pretty close to the molality. In very dilute aqueous solutions, the molality and the molarity will be roughly equal because 1 liter of water and 1 kilogram of water is the same. The density of water is 1 kilogram per liter, so if it's a very dilute solution, 1 kilogram and 1 liter are about the same. Converting between molarity and molality will always require information about the volume of the density of the solution. Note we were able to find molality and molarity because we knew both the mass of the solvent and the volume of the solution in this example. Let's consider some additional examples. What's the molality of a 2 molar sodium chloride solution with a density of 1.08 grams per milliliter? See, here we have a molarity and a density. To convert to molar from molar to molal, assume 1 liter of solution. Given this hint, attempt this problem before continuing. So as stated in the hint, we will assume we have a liter of solution. What we know then is that we have 2 moles of sodium chloride with a mass of 117 grams. If the density is 1.08 gram per milliliter, our 1 liter of solution is equal to 1,000 milliliters of solution. And we can multiply this volume, 1,000 milliliters, by the density to obtain 1080 grams of total mass. Then the mass of water is 1080 minus 117, or 963 grams. And so the molality is 2 moles of solute divided by the solvent mass, which is 0.963 kilograms. And we have a molality of 2.08 molal for the sodium chloride. Now let's consider molarity for molality. Consider a 22.1 moles ammonia solution in H2O solvent. The density is 0.982 grams per milliliter. What is the molarity? Again, here we have a molality and a density, and we want to find molarity. You should stop and attempt this problem before continuing. The hint is to convert molal to molar, assume 1 kilogram of solvent. So as stated in the hint, we will assume a kilogram of water. We then know that there are 22.1 moles of ammonia, which we can convert to grams, 376 grams NH3. We've assumed a kilogram of water. That means that we have 1,000 grams of water. Or our total mass is 1,000 plus 376, or 1,376 grams. We can find a volume of the solution by taking the mass and dividing by the density. 13.76 grams divided by the density of 0.982 gives a volume of 1.4 times 10 to the 3 milliliters, or 1.40 liters. We then obtain molarity by dividing moles solute, 22.1, by liters of solution, 1.4, and obtain a molarity of 15.8. This example shows that in very concentrated solutions, 22.1 molal, molarity and molality are not close to the same. Again, in dilute aqueous solutions, molarity and molality should have similar but not identical values.